if x, y, z are the midpoints of the sides, the three civilians are concurrent. So assume that we have a triangle ABC. We have triangle ABC is a triangle A, B, C, and it is given that x, y, z are the midpoints of the sides. So assume that the x is midpoint. So this and this portion is equal and join x. Similarly, let us assume that by y is midpoint of AC and CZ, where Z is midpoint of AB. So this means BX and XC are same. That is BX is equal to XC. Then CY is equal to YA. Z is equal to ZB. Okay, because X, Y, Z are the midpoints, the corresponding sides. That is BC, CA, and AB. Therefore, we have to show that these three Cevians, we already know that these Cevians are called as medians. So, the line segment joining the vertex to the midpoint of the opposite side is called as a median. So, we have to prove that these three medians are recurrent. Therefore, they must satisfy the Ceva's theorem. Now, we'll find out whether it satisfies the Ceva's theorem or not. So, we'll find this ratio Bx upon Xc into Cy upon Ya into Az upon Zb is equal to, now Bx is equal to Xc, therefore Bx upon Xc is equal to 1 into Cy is equal to Ya, therefore Cy upon Ya is equal to 1 and Az is equal to Zb, therefore Az upon Zb is equal to 1. So that is equal to 1. Therefore, Bx upon Xc into Cy upon Ya into Az upon Zb is equal to 1. Therefore, this condition is satisfied, that is condition of concurrency or say Ceva's theorem. Therefore, the three Cevians which are in this case are medians. So median is a special form of a Cevian. The three medians are concurrent. This is problem number 2 from Geometry Revisited book, section 1.2. The problem states we have to prove that Cevians perpendicular to the opposite side are concurrent. So firstly, we will draw the triangle with visual notation, that is ABC. Let us say this triangle ABC. Let us say this altitude is X and the altitude from vertex B is say BY. Then the altitude CZ. So these are the three altitudes in a given triangle ABC. We have to prove that these three perpendiculars or say altitudes are concurrent. Here we have AX perpendicular to BC. We have AX perpendicular BC, BY perpendicular CA, and CZ perpendicular AB. That is given the condition in the problem. Now we have from triangle ABX is a right angle triangle. So we know that AX divided by BX is equal to tan B. This implies BX is equal to AX upon tan B. Similarly, from triangle ACX, AX upon CX is equal to tan C. This implies XC is equal to AX divided by tan C. Therefore, BX divided by XC is equal to AX upon tan B divided by AX upon tan C, that is equal to tan C divided by tan B. That is BX H2 XC is equal to tan C H2 tan B. Similarly, CY H2 YA is equal to tan A H2 tan C, and AZ H2 ZB is equal to tan B H2 tan A. Therefore, BX upon XC into CY upon YA into AZ upon ZB is equal to, we'll write each ratio, that is tan C upon tan B into tan A divided by tan C, and AZ upon ZB is tan B upon tan A. Now we'll cancel out the same terms from the numerator and denominator, that is tan C upon tan C, tan A upon tan A, tan B upon tan B, and that is equal to 1. Therefore, the condition Bx upon Xc into Cy upon Ya into Z upon Zb is equal to 1 is satisfied. Therefore, the CVNs Ax, By, and Cz are concurrent. That is, the altitudes of any triangle, altitudes of any triangle are concurrent because they satisfies the condition of concurrency. Hence the result. Now we will solve problem number 3 from section 1.2. Problem states, let ABC and A dash B dash C dash be two non-congruent triangles whose sides are respectively parallel as shown in figure 1.2b. Then the three lines A dash, B dash, C dash extended are concurrent. Such triangles are said to be homothetic triangles. So here the diagram is given and the condition is given also that the triangles are non congruent means they are similar triangles because the sides are parallel. We are given that BB dash and CC dash meets in O. Join A to O, join A to O, and let us assume that O meets A dash B dash in A1 dash. Now from triangle OBC and OBC, OB dash. Now from triangle OB dash C dash and OBC. Now since BC is parallel to B dash C dash, therefore triangle therefore triangle OB dash C dash is similar triangle OBC. Therefore, because of the similarity, we can say that OB dash upon OB is equal to B dash C dash upon BC is equal to OC dash divided by OC. Let us say this is equation number 1. Triangle OAB, say OA dash B dash, similar triangle OAB. Therefore, OA dash upon OA is equal to A dash B dash divided by AB is equal to OB dash divided by OB. This is condition number 2. So from 1 and 2, A dash B dash, A dash B dash upon AB is equal to B dash C dash upon BC is equal to OB dash upon OB. Let AO meets A dash B dash in A1 dash. So here we are assuming that if we join A to O, then this point is say A1 dash. Whereas we are assuming that this point A and this point A dash, A1 dash are different points. Therefore, triangle triangle O triangle O A1 dash B similar triangle OAB OAB. Therefore, OA dash therefore OA dash upon OA is equal to A dash B dash upon AB is equal to OB dash upon OB. Sorry, what? We have O A1 dash upon OA is equal to A dash B dash upon AB is equal to OB dash upon OB. This is equation number 3. From equation 2 and equation 3, we just OB dash upon OB is equal to some ratios. So similarly here for from 3, OB dash upon OB is equal to these ratios. Therefore, OA dash upon OA is equal to OA1 dash divided by OA. So equating these two ratios, that is OA dash upon OA and OA1 dash divided by OA. That is, so if we observe this condition, that is OA dash upon OA is equal to OA1 dash upon OA. Therefore, OA dash is equal to OA1 dash. Therefore, A dash and A1 dash must coincide. Must coincide because the lines A dash, B dash, and C dash, the lines A dash, B dash, and C dash are meeting in point O. Hence, they are concurrent. Hence, they are concurrent. Hence, we will solve problem number 4. That is, let X be a CVN of length P, AX be a CVN of length P, dividing BC into segments BX equal to M and CX equal to N as shown in figure 1.2c. Then A into bracket P square plus Mn is equal to B square M plus C square N. So in this case, we are given the values of A, B, and C. A is the length of BC, so that is A. That and it is divided into parts, that is M and N, that is Bx plus Xc is equal to A, and Bx is M and Cx is N. That is given. So therefore, M plus N is equal to A. We have to find the length of CVN AX, which is denoted by letter P. So here, in this case, the unknown will be P and other things A, B, C, M and N are known. So we have to find the relation between A, B, C, P, M and N. So it is normally we are thinking that we assume that we can draw any line from the vertex to any point on the other side or opposite side, say, and this line is called as CVN, which is general line. So it is of great interest how to find the length of CVN. So this X equal to P is actually the length of CVN. Angle AXB is equal to theta. So this angle is theta, and then this angle will be 180 minus theta. That is angle AXC is equal to 180 degree minus theta. Because BC is a straight angle or BXC is a straight angle. That is AXB plus AXC is equal to 180 degree. Now we'll apply the cosine law for triangle ABX. So in this triangle, we can say that AB square is equal to x square plus bx square minus 2 into ax into bx cos theta. Therefore, c square is equal to p square plus m square minus 2pm cos theta. Let us call this as equation number 1. Now assume that we are also applying the cosine law for the triangle ACX. We get AC square is equal to x square plus cx square minus 2ax into cx into cos of angle AXC, that is 180 degree minus theta. 180 degree minus theta. Therefore, b square is equal to p square plus n square minus 2pn cos 180 minus theta. Therefore, b square is equal to p square plus n square plus 2pn cos theta. Since cos 180 minus theta is equal to minus cos theta. So after using this, we get this simplified equation. So that is equation number 2. If we observe equation number 1 and equation number 2, other than cos theta, everything we are desired to have. Therefore, we must eliminate cos theta from equation 1 and 2. And if we eliminate cos theta from these two equations, we will get the required result. So how to get that? So if you observe in the first equation, the coefficient of cos theta is 2pm and the coefficient of cos theta in second equation is 2pn. So therefore, if we multiply the first equation by n and second equation by m, and if we add together, then minus 2pmn cos theta and plus 2pmn cos theta will get cancelled, and after making simplification, we will get the result. Multiplying equation 1 by n and 2 by m and adding and adding together, we get n c square plus m b square is equal to n into bracket p square plus m square minus 2pm cos theta plus m into bracket p square plus n square plus 2pn cos theta is equal to, we multiply, that is n p square plus m square n minus 2pmn cos theta plus mp square plus mnn square plus 2pmn cos theta. Cos theta. Now we will collect the like terms together. Therefore, p square into bracket m plus n plus from this m square n and mn square we get mn as common, mn into bracket m plus n. Now minus 2pn pmn cos theta and plus 2pmn cos theta will get cancelled, which is required. That is equal to m plus n into bracket p square plus mn. But m plus n is a, that is length opposite to the angle A, that is equal to a into bracket p square plus mn. Therefore, we say that a into bracket p square mn is equal to nc square plus mb square, which was required to be proved. Therefore, a into bracket p square plus mn is equal to nc square plus mb square. Here's the result.